go back to clear this, and you've got x to the 3 minus 9 over 2. Graph that. Second calc, 0 that, and bring it to the left of that intersection with the axis, and then to the right of the intersection of the axis there, and there it is, 1.6509. Okay, so that's what I'm asking you to do there. All right, let's go on with some more problems, more examples. And since you guys are supposed to be doing this and you're not here, so I have the pleasure of doing 43. Okay, so number 43, and the function is, so let me go snip this guy. Okay, and I'm doing number 43 right there. Okay, so let's go formulate it. Okay, so remember, A is 0, B is 2. Your integral is going to be x minus 2 root x dx from 0 to 2. That's your left hand side. On your right hand side, you're going to go b minus a, so that's 2 minus 0 times f of c. Okay, which is really going to turn out to be c minus 2 root c. So you can see that I think analytically this might prove to be a challenge, so we can always use the n box to do it. Okay, let's see what happens. So I need to rewrite this guy to be x minus 2, x to the 1/2 dx. So then this becomes x squared, and the limits are 0 to 2. So this becomes x squared over 2. Increase this by 1, so that becomes 3/2. Divide by that, so then this becomes 4 over 3. Okay, dividing by 3 over 2 flips it over. This guy becomes x to the 3/2, and you're going to put in your numbers 2 and 0. Okay, and so that's equal to 4 over 2 minus 4 over 3 times square root of 8. Okay, so square root of 8 is 2 root 2. Well, let's just leave it as square root of 8, because I think analytically this may prove to be a little difficult for many people. So let's just go do it with a graphing calculator. So again, the number here is 4 over 2 when you put 2 there, and you put 2 in here. 2 cubed is 8, and then you have a square root of 8, so 4 times square root of 8. And this is equal to minus 2 root c, and you need to solve this equation. Okay, so we're just going to do it on the calculator and see how that works out. And for those of you guys who have really mastered how to solve this equation from pre-calc, this is totally doable in pre-calc, from pre-calc, okay, or even really algebra 2. So for those people who feel the urge to do that, I urge you to do it. Okay, so let's go rewrite our equation. Okay, so our equation is going to be x minus 2 root x. Okay, bring the 2 over from this side onto the other, so it becomes a minus 2, and then bring the other stuff over, so it becomes a plus 4 times root 8 divided by 3. Okay, so let's just go check that. So x minus 2 root x minus 2 plus 4 root 8 over 3. I'm going to go graph that. And remember, your answer is going to be between 1 and 3. Ooh, things are not looking really good here. What's going on? Okay, time for another pause, and I need to fix my errors. Okay, so I think I see where my problem is. On the right hand side, I forgot to put this 2 in there, so there should be a 2 here. Okay. So there should be a 2 there. Okay, so then the equation becomes, if I divide everything by 2, then I get 1/2 minus, wait a minute, God, I am hella slow today, oh my God. Okay, so divide by 2, so that gives me a 1 minus 2 over 3 root 8 is equal to c minus 2 root c. So the equation I need to create in my graphing calculator is this guy here. I bring the minus the 1 over, I bring the other stuff over, so it becomes this. And let's go revise my y1 in here. Okay, so I've got x minus 2 root x, then this should be a minus 1, and the other guy should be a 2 there, and let's go graph that. And so obviously you can see that the scale needs to be changed, so I'm going to go change my y scale there. So I'm going to make my y to be let's say -1 to maybe 2. See if that improves things. Yeah, there we go. Now we can see that it's intersecting at 2 places, and what we're going to do is just going to do second calc 0 on this thing. Okay, so we're going to go second calc number 2 and bring it down closer to the intersection point there. Left bound, right bound, enter, enter. And so my first answer is 4378. Okay, 430.4378. That's my first answer. My second answer, I'm going to go second calc this guy again, number 2, bring it over to the other intersection point, enter, 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 and I get 1.7908. Okay, 1.7908. 1.7908. So those are my 2 C values, and they are both between 0 and 2. Okay, so that seems reasonable. Let's go take a look at the answer, and the answer is number 43, 4380, 17980. Okay, so that was pretty good. Took me a while to see that error, but hey, I think I'm kind of slowing down here, like an old man. All right, okay. So the other concept that's related to the mean value theorem is the average value of a function, okay, the average value of a function. And that's given by this formula. Now this is not significantly different from what we did with the mean value theorem. It's just a rewrite of this. Okay, it's just a rewrite of it. Okay, so quickly let me review what that means. Remember, the mean value theorem we agreed was something like fx dx, okay, from a to b is equal to b minus a times f of c. So the average value is just defined by dividing both sides by b minus a. Okay, dividing both sides by b minus a. And then you get f of c is equal to 1 over b minus a, integral of fx dx, a over b. So really it's nothing new, it's the average. So the reason why it's the average value is what it's saying is that, hey, if you have a graph, okay, and you have an integral of that, okay, let's say that this is a and this is b. If you have an integral over that, it's saying that there is some value of c, okay, such that if you want to draw a rectangle, okay, the area of that rectangle is going to be the area underneath the shaded graph, okay, underneath the graph. So, and so then this value here is called the average value of the function. Okay. All right. Okay, I did get this going. Okay, so it's just a rehash of the mean value theorem. Okay. Example number 50, page 291. Number 50, page 291. Trig function. Okay. I love trig. Love trig. Okay, so we are doing number 50. Find the average value of the function of the given interval in all values of x in the interval for which the function equals its average value. Start out by definition. Definition is f of c equals 1 over b minus a, integral fx dx from a to b. Okay, just from the definition. So remember, a is 0, b is pi over 2, so b minus a becomes pi over 2, and if you're dividing by that, that becomes 2 over pi. You're going to integrate cosine x dx from 0 to pi over 2, and this guy becomes 2 over pi, and the integral of cosine is sine, and sine of pi over 2 over 0, and you know that sine of pi over 2 is 1, sine of 0 is 0, so you get this is 2 over pi. And then this is the average value of the function, so this is your answer right here. Okay, that's your answer. Okay, that's equal to the average value of func. Okay. Well, let's see if the answer is right. So that's number 50 on 4.4, number 50. 2 over pi. That's what I have. Okay. All right. So this is the end of the second day of 4.4. I still have one more day to do some more topics in here, and that's the fundamental theorem of calculus, FTC, and I'll record that as a separate session. Well, enjoy, and again, I want to emphasize that you watch this before you come back for the week of the 27th, when I'm not going to be there. So that whole week you're going to be working on 4.4, and since it's a pretty long topic, I suggest you view 4.4 on the weekend, and then redo that in the evenings on Monday, Tuesday, and Wednesday. Okay, so enjoy. Bye.